Well, I suppose it's close enough to being on time here to get going. So I want to welcome everybody to the first of our monthly webinars for the Large Outdoor Fire and the Built Environment Working Group. I'm Sarah McAllister. I'm co-hosting these webinars with Sam Manzello and Sayaka Suzuki. So just some orders of business before we get going. For the especially this first one, please be patient with us as we try to figure out the best way to run these. I will record these webinars, so if they don't, if you're unable to make the time zone for future webinars, keep that in mind. We'll have them recorded and we will post them. We're going to try to hold to our 1 hour time zone slot, and our Q&A will be through the chat box. So type your questions into there, and when the speaker is done, I'll read them out and we'll go through the questions one by one. And if for some reason we don't get through all of the questions, I will save them, and the speaker will answer those questions in writing after the webinar is concluded. So please remember to try to keep yourself on mute. We're expecting a number of people, so it'll kind of turn to chaos if somebody's not on mute. Without further ado, I'm going to briefly introduce the first speaker, who is Sam Manzello, who is one of the co-organizers of this, and he's going to introduce a little bit about the working group and some of the work that we've been doing. Sam received his PhD in mechanical engineering for the University of Illinois, Chicago, and he's been at the National Institute of Standards and Technology, or NIST, since 2001. I like to think of him as the father of the NIST Dragon, because he's done many studies looking at the ignition firebrands. He's editor-in-chief of the first comprehensive encyclopedia on wildland fires and wildland-urban interface fires. And with that, I think I'm going to just hand it back over to Sam and let him get going.
Okay, thank you, Sarah, and Sayaka as well, and thanks everybody for joining today. As Sarah mentioned, this is our first LOF&BE webinar, so please be patient with us. We are going through some learning processes as well. So before I go into it, there's a couple important things I'd like to announce. I really would like to acknowledge my LOF&BE co-leaders, Dr. Suzuki and Dr. McAllister. I like these particular pictures. Dr. Suzuki works for the National Research Institute of Fire and Disaster in Japan, and Sarah works for the USDA Forest Service in the USA. And also I'd like to acknowledge, for those of you that can read Japanese, it just says thank you very much, arigatou gozaimasu, to the National Research Institute of Fire and Disaster and the Building Research Institute for many years of fruitful collaboration. And also, I would like to dedicate this past year, really a good friend of mine, Mr. John R. Shields, the middle name is Randy. Randy passed away, and really way too early, of course. Randy was a really good friend of mine at NIST, and actually one of the few people that actually came and helped me from NIST for a lot of the work that I've done in Japan. And this is a picture of Randy and I doing some really early scoping experiments in the Building Research Institute wind tunnel many years ago. Randy was a really nice person, and I really think NIST had lost someone really special. He would help anybody, and he had a love of experiments. There's no way I could give this webinar today without really thanking Randy, and being in Japan and working here, you know, pretty much there isn't a day that goes by that I don't remember some of Randy and I's funny stories. So I just really wanted to thank him. Just some background about me. Sorry, it's a lot of details, but basically, my background, I didn't come from a fire research background. So I was a mechanical engineer by training, and I did my research. It was funded by NASA, so I had a fellowship from NASA to look at microgravity combustion. Those of you that know Sarah McAllister also know that Sarah had a similar background doing work for NASA. And I've been at NIST since 2001, and became very interested in fire research. So this is basically why I joined NIST. And no reason to read all of this stuff for anybody, but just to give you some idea of who you're listening to, or what's my take on this particular problem. So the web.
Sam, real quick, sorry to interrupt, but your sound is cutting a little bit in and out. If you could maybe try speaking up a little, maybe that would help.
Okay. So the presentation will be outlined into the following topics. So basically, I'm going to briefly talk about why did we create this IFSS LOF&BE permanent group? And I'm going to give then a brief research overview about some of the research we've been doing on firebrand processes. And we'll close this webinar with what is sort of going on with a new working group in ISO called ISO TC92WG14. And hopefully the audio is better. I'll try to speak a little bit closer to the speaker. Maybe I'm too far away. So the genesis of the IFSS LOF&BE working group. And I think many people are interested in how this started and where this sort of came from. So large outdoor fires in the built environment, I think for the people attending this, clearly know that this is a global problem. For many of us or colleagues that are actually working in the US, wildland fires that spread into communities known as we call them WUI fires, have destroyed communities throughout the world. And in other areas in the world, there's been a large-scale urban fire problem. And a more recent addition to this outdoor fire and built environment issue is related to informal settlements. So if you see the image in the informal settlement fires there, for example, in South Africa. So these outdoor fire problems are sort of proceeding and growing throughout the world. And here is a diagram showing us sort of the nature of various kind of fires that are occurring. So for example, you have WUI fires in California, as everybody is familiar with. You have a lot of these informal settlement fires in South Africa. You have fires once again in Australia. You've actually had large-scale urban fires in Japan, actually for hundreds and hundreds of years. But there was a recent one in 2016. And also it was interesting to see there was a WUI fire in Korea in 2019. That was a big deal. So clearly a global problem, and you can see these happening sort of any sort of place around the world. If you look at some recent images, this is California fires in 2018 versus the South Korea fires in 2019. So a lot of destruction and important aspects related to these types of fires. So several years ago, through ASTM, we actually had a workshop which was hosted by the ASTM International E5 Standards Committee. And Steve Quarles, who works in IBHS, who recently had retired. Steve and I organized this workshop, and hopefully Steve is on the webinar as well. We invited speakers, basically. There was a call for presentations, and speakers basically delivered nice presentations. And then we summarize the findings of what we learned from this workshop and this NIST report. And one of the main findings in that workshop at that time was that, current WUI codes and standards are not really adequate to deal with the current problem. We then explored the idea. We had a special issue on this in fire technology. And I think many of you are familiar with a lot of the papers that came out of this. There's one highly read paper by Sarah Caton, looking at a summary of a lot of the research actually that NIST has done on the problem. And there's several other studies as well. And so this was published in March 2017 in Fire Technology. So those of you that are not familiar with it, I encourage you to go look at this because it's a good resource to understand about research related to WUI fires. Working with the International Forum of Fire Research Directors, clearly WUI fires are sort of a growing issue. So we worked with NFPA, CSTB, and VTT to develop a position paper. And basically, for those of you that are not familiar, a position paper is just an opinion of what the collective people feel that we should work on for WUI fires. Since the WUI fire problem was obviously becoming bigger and bigger across the world, it was important to basically identify some key research needs that we need to work on, because there's a lot of things that we don't understand as a community about these problems. So this was the main focus for this. If you haven't seen this paper, I also would encourage you to just look at it, because there's a lot of research needs that have been identified for woody fires in general. So this brings us to how LOF&BE itself was formed. So in 2007, if you're familiar with the IFSS, they have conferences every 3 years. And normally it's a tradition of the conferences to have a workshop series before the conferences. So I was asked by IFSS to host a workshop at the Lund Symposium in 2007. And basically as part of that, since I had worked on these other events specific to woody fires, I thought it was a good idea. Well, we should look at this from really a global perspective. So what we did as part of this is that I looked around and I invited colleagues from different parts of the world to give us their take or perspective from Asia to Oceania to European to North American to South American views on the problem. And what we did basically, as you see on the left, we developed a workshop report. And then we developed eventually a summary paper for Fire Safety Journal, because IFSS and Fire Safety Journal, they're the official journal, so we submitted it there. And what we learned actually from the workshop was that, not only are the outdoor fire problems important across the world, but the participants asked us at the time, it'd be great if we actually have, rather than just a workshop, before the IFSS, for example, in this case, we should have a permanent working group. And those of you that are aware with IFSS, there's the MAX-CFP working group that's permanent. And so the idea was that, the outdoor fire problem really deserves to have a permanent group related to that. So from that initiative and drive of the participants and from the need for this, we basically decided we want to try to explore this to be a permanent working group. And obviously you probably would guess that Drs. McAllister and Dr. Suzuki were with me as part of the original people on this IFSS workshop. So they presented and also provided views from their respective regions. So you might be asking, what the heck is LOF&BE? Maybe you think it sounds funny or whatever. But basically, it just stands for Large Outdoor Fires and the Built Environment. And we called this LOF&BE to have a sort of interesting name. And we're focused on many different kind of fires in this activity. So as I mentioned, there's a lot of focus on wild and interface fires. But in many countries, especially, for example, in Asia, urban fires are a big issue. So for example, like in a country like Japan, there isn't a big woody fire problem, but there's still an urban fire problem. And also there's this developing area of informal settlement fires, which are seen in many countries, for example, like in South Africa or in the Philippines. And so these are the topics that we're trying to cover within LOF&BE. So one of the problems, of course, is that as fire researchers that are on the call know, for many, many years, fire safety science has done a lot of research into understanding the fire dynamics in buildings. And outdoor fire research is just, is in the fire safety science community has been studied much less. And as I'll talk, part of the reason, of course, is it's very complicated. So, when you're doing inside building fire research, you're looking at fire that's contained inside, let's say, a building or inside a compartment. But when you're dealing with outdoor fires, it's a much more complicated issue. And as you can see, it's infecting many people throughout the world through various aspects. So, for example, evacuation, property losses, of course, deaths, and also inhaling products of combustion. So these are some of the examples we list of some missing knowledge. So for example, in outdoor fires, fire spread processes are very complex because you have to consider the interactions of the topography, the weather, the vegetation, as well as structures. And structure-to-structure fire spread can actually occur under similar mechanisms as in urban fires for woody fire spread. And those of you that are in California, for example, or the Western states, there was a lot of, there's effects of smoke. So for example, the images I've seen of San Francisco and whatnot, a lot of smoke and particulate production. And of course, one thing we're interested in as well is outdoor firefighting. So, in the case of many countries, some countries actually have structure firefighters and they also have wildland firefighters. Some countries have just only one. And so, for example, when we're talking about a wild and urban interface fire, we have the interaction of, the built environment, and also there's still a wildland fire related issue. So how do we deal with that, for example? What type of tactics or what type of PP is needed for this? So, the needs of the fire service are really critical, and we think are very important. And of course, there's also a lot of evacuation issues. If you looked at some of the fires that occurred in Canada, for example, the McMurray Canada in 2016, you could see the long evacuation streams and other kinds of things. So what type of situations need to be dealt with? So what we developed basically as a first cut for this is we have three working groups, which we call the Ignition Resistance Communities Group. We have the Emergency Management and Evacuation Group, and we have the Large Outdoor Firefighting Group. And so the idea is that how can we bring, there's a huge amount of knowledge in the IFSS community on different aspects of research. How can we bring that knowledge to better interface these topics? And one of the focuses, of course, is in the firefighting area, because we feel that firefighting is an area that's really been, I don't know if it's overlooked, but just hasn't been so much integrated into the IFSS structure for whatever reason. So those are the goals. I mean, you can read that there. I'm not going to go into it, but this is what the three topics are basically looking at and working on. So the general approach currently is that we're in the collecting information phase. So for example, trying to understand what are all the codes and standards, best practices, and current research on these areas. And then eventually we'd like to identify gaps or things that we should be working on. And then also try to work on specific products to solve the gaps as part of the IFSS LOF&BE working group. Currently, we have a broad, diverse membership. So we have more than 100 members across many countries. And then in order to sort of try to lead this, because it's a huge activity, we have each group is led by several sub-leaders. So for example, the IRC group, we have Alex Philkoff from the University of Melbourne. We have Daniel Gorham from IBHS and David Raj from the University of Edinburgh. And for the large outdoor firefighting, we have Jingyuan Wang from Hong Kong Polytech and Brian Latimer from Regina Tech. And EME, Saka is sort of doing double duty currently. So she is leading that with Maria Theodori of Reacts Engineering. And so as the process, as you can imagine, is a very large activity, we also like to thank, we had some initial group leaders as well that were working on it. And so we'd like to thank them here as well for their initial service and many great ideas. So it's a very diverse and very large sort of activity. If you're interested, this is the current progress since we formed it. So we had a mini workshop at the AOFST, which is the Asian branch of the IFSS symposium in 2018. And then we had another mini workshop at Interflam. Interflam, of course, is not related to IFSS, but we asked if we could have a workshop because Interflam audience is also very interesting as well and very important to address the problem. And then recently, because we were supposed to have IFSS 2020 this past April, but as you obviously know, we couldn't have it. So we had a virtual workshop. We actually had two to deal with the time zone differences. So, and then we just issued a report as well. So if you're interested, we could send you those reports. So some of the current progress is that we're working on different review papers. So IRC is making great progress. They have 14 volunteers working across the globe to develop a review paper. EME has actually just finished their review paper from 11 members across the globe. We have people coming from Israel, from many countries helping us with this. Then LOF is also now working on developing an outline for a large outdoor firefighting related review paper. So as I mentioned, because the IFSS is going all virtual, we had planned a 1.5-day workshop as part of this, but because obviously no one's going to want to sit for a 1.5-day virtual workshop, and it's not going to be possible to do that. What we're doing is we're migrating talks from our workshop to this webinar series. So these are the next series of talks that are coming. Sarah and Saka volunteered me as the tester for the first one. So this is why, sorry you guys are listening to me, but I'm the first guy to go with this and see how this is going to go. Saka is going to talk about urban fire management in Japan next. And we're going to have a talk on indigenous fire stewardship from Amy Christensen. Sarah is going to give us an overview of the recent fires out west in the US. And Rafael is going to talk about some of the fires in Australia. Elsa is going to give us an overview of Spain. And Yu Wang from China is going to actually talk about the informal settlement issue, and also from an Asian view, which I think is going to be very, very interesting. So I hope you tune into that. And DK Ezekoya is going to give us a talk about wayfarers in Texas. And we're also adding more webinars as well. So there's a whole series of people that have volunteered that we're going to be adding next. And if you're interested in giving a webinar, we would love to hear from you. And so please let us know if you'd like to do this. So it's free to join LOF&BE. That's the link. And an important thing I want to announce today is also, this problem is huge, as you know. So we need industry, we need fire service, and we need standards and codes bodies to work together. We can't solve this problem alone. And what LOF&BE is also going to be doing is we're creating a new fire service advisory panel. So what we'd like to do is have members from the fire service as part of our panel to actually look at some of the work we're trying to do with the LOF&BE activity and give us advice. You know, hey, that looks like you guys are going in the right direction, or hey, you know, maybe what you're doing here nobody cares about. Because I think that kind of feedback is important, and I myself in my career have tried to do that kind of input and feedback for a long time, because it's important, especially from the research community, that we try to work on the right problems. So with that, I'll talk very briefly about some of my current research, now that we'll switch gears out of LOF&BE. So what we've been doing recently is really related to a lot of research on firebrand processes. I'm going to be talking about a lot of experiments that we've done and show some pictures of some of the processes. So I think everybody's aware that, you know, firebrands are a major issue in terms of not only the spread of these fires, both for, you know, wood fires, informal settlement fires, even for urban fires, but also, you know, ignition of structures and things like this. So these are some images, for example, when you talk about generation processes, that, you know, that's an experiment that was done to look at firebrand generation from burning trees, versus that's an experiment that was done on the right to look at firebrand generation from burning structures that are important in both of these type of situations. And also we talk about processes. I think everybody's familiar with accumulation processes. So I'm just showing everybody some experiments that we've done looking at these transport and accumulation processes, looking at how firebrands actually accumulate and contribute to ignition phenomena. And so these are just some interesting, I think, images to show these kind of effects. And then, of course, there's ignition processes. So as part of the work we've been doing for the last several years, and I'll talk about this, you know, we started looking at basically simplistic laboratory type of experiments. And this is an image from a paper in the International Journal of Wildland and Fire back in 2006. And then we found a need to develop something that we call the Dragon, which, if you're not familiar with it, I'll talk about what it is. And you can see some of the stuff that the Dragon is doing there. So the Dragon has the ability to make showers of firebrands. And there's a reason why we wanted to look at that kind of process on ignition. And if Kathy Butler's on the line, I hope she is. Kathy sent me this very great picture from the campfire in 2018. And basically, our research efforts are concerned with these kind of processes. So here you see actually a shower of firebrands that are actually occurring in a real fire. So, you know, I think most of the people on the call are familiar with these processes, and I don't have to go into detail too much. But basically, you know, how do we look at this experimentally, and how do we develop mitigation strategies and understand these kind of issues? So, once again, another paper that I think would be interesting for people to read. We recently developed a review paper on this. And if you're interested, I'd be more than happy to send it to you if you haven't already seen this. And the idea with this paper is that we try to basically put everything. So, I mean, when you think about it, just the idea was, what did we want to put in here? And also, what's important is, Japan is a country that's been greatly affected by these kind of fire situations, especially firebrands. And there's a lot of knowledge that actually exists in Japan that was not in the open English literature. So my colleague, Dr. Suzuki, actually translated a lot of these studies and then basically, like, you know, discussed that in this paper. So if you're interested in that, I definitely encourage you to look at the paper and try to understand about some of the stuff that's been done on this topic. And also, this is a new paper that we published on firebrand accumulation effects on ignition. So one thing we believe is that, you know, there needs to be new theoretical approaches to the problem. And so this is an attempt, a first cut attempt to develop some new theoretical approach looking at the effects of accumulation on ignition. And also, this is just to give a plug for a new journal that's developed by the Combustion Institute. This is a sister journal of PECS, which is called Applications in Energy Combustion Science. And it's a 100% open access journal. So they're publishing papers related to fire studies. Unfortunately, ours is the first one in fire, but we hope there'll be more papers coming out in fire. So when we look at firebrand generation processes, today, since we don't have so much time, I'm just going to talk about some of the research we've done on firebrand generation from structures. So as I think everybody's aware, when these fires are occurring, the structures themselves can be a source of firebrand production. And there's been several studies, for example, even a recent NIST study that basically indicated that, for example, in the Colorado fires, that basically structure firebrand production was important. And in Japan and other countries, here's a picture of the fire in Japan in 2016. So that's Itogawa fire, which was the largest urban fire in Japan in the last 40 years. And you can see that vegetation isn't playing a role in this. This is all structure combustion. And so the idea is that how can we understand the production of firebrands from structures? So obviously, an interesting way or a cool way is you can actually burn actual structures. So I was invited as part of being in Japan to observe a full-scale 3-story schoolhouse burn. So they actually constructed a full 3-story house and basically burned it down. Now this was really cool to watch, but obviously from a budget perspective, I mean, this was basically like 3 billion Japanese yen to do this experiment. So my understanding is like around $26 million for one test. So I don't have that kind of research budget. So the thing is that I can't do those kind of experiments, even though that's sort of the real scale deal. So the idea is that how we can get insights into this problem from laboratory scales. And so one thing that we're interested in trying to understand is that could we develop a test method, for example, that would let us compare and evaluate a different material's ability to actually produce firebrand? Such that one way you can mitigate firebrand issues is you can basically have building materials that just simply don't produce firebrand. So interesting idea perhaps, but the idea is that how do we do that? We want to develop experimental methods that don't cost, let's say, $26 million, and we can do it in a repeatable and simple fashion. So what we did basically is that we developed a protocol to help us look at mock-up of building assemblies. So the idea here is that these are relatively small scale experiments, not burning an entire structure. And the idea is that can we ignite and then collect the firebrands and look at these production of firebrands from these type of mock-up assemblies. And what we're talking about here is you can see about 122 centimeters by 61 centimeters. So this is just a very small type of a corner type of assembly. And the idea is that can we look at the firebrand production from this? So we can do these kind of experiments, and also we've done it under wind effects. And so you can basically ignite and then collect firebrands that are being produced. And these are the kind of firebrands that you can see that are being produced from this structured firebrand. And this is just a typical experiment that we've been conducting looking at these kind of effects. But of course, you want to be able to compare it to full-scale experiments. So we've spent a lot of effort doing a series of full-scale experiments of different scales to see, well, how does like such a simple experiment of a mock-up actually compare to something that's real scale? And so there's a lot of information here. And there's papers that we're comparing this to. But the idea is to basically see that you can get some insights from such a simplistic mock-up experiment, comparing to a much more complex sort of full-scale experiment. And the image I'm showing in the top is actually, that's a mock structure that we actually burn in a wind tunnel. And the image on the bottom is actually another corner wall, but it's bigger in size than what we're doing with the mock-up results. And basically, you can use these mock-up results to get insights into firebrand production from different types of mass classes or size classes. So for example, even if it's a much simpler experiment, you can get insights in terms of the firebrand production characteristics. So this is important if you want to look at ignition by firebrand. It's also important if you want to look at the transport type of calculations that somebody would like to do. As you can imagine, we've also developed a protocol not only for walls, but also for sort of simulated roofing assemblies. So we've also done experiments looking at different size roofing assemblies as well to develop a strategy. And here, once again, we have a burner assembly, and we ignite this, and then we look at the firebrand production. And you can see the kind of firebrands that are being produced from these kind of experiments. These are some experiments we've actually done at 8 meters per second to get an understanding of these problems. So there's been a lot of recent papers that we published. Since the webinar, we clearly can't go into the details here, but if you're interested, these are papers that actually just came out. One is in Fuel, looking at the comparison of the different scales. And the other is also using our protocol to actually look at trying to understand, for example, cedar roof covering applications, for example, for outdoor fires. And this is published in the Journal of Cleaner Production. So one thing we all know is that wood is obviously a sustainable material, and it's been used in construction for many, many years. But because of the various aspects related to fire, how can we look at understanding firebrand production from building materials using a very simple, much cheaper experimental protocol? And the message I'm trying to give to everybody here today is that cheaper, simpler experimental protocol. So how can we understand that in a simple way without having to burn entire structures or something like that, which is just not practical, not only from a budget point of view, but just really from a time and other kind of aspect point of view. And also, one thing we've done recently is that we did some experiments looking at surrogate PV panel assembly. So the idea was that, is it possible that these type of assemblies could produce firebrands? This is something that most people really haven't really considered. So it's just something that we looked at in a recent paper that was also published in the Journal of Fuel. So now I'll switch gears a little bit and talk about firebrand deposition and ignition processes. As a recent paper, Dr. Suzuki prepared this graph, which I personally like because it's really simple to understand. And what we're looking at here basically is that when you look at structure ignition, we have direct flame contact, we have thermal radiation, and then we have firebrand processes. And one thing that hasn't really been looked at in detail is the coupling of the thermal radiation and firebrand on ignition. So these are some experiments that we've been also doing recently. This is also open access in fire technology, so it's free. So you can just download this paper if you're interested in it or if you haven't seen it. So Sarah alluded to it about the dragon, and I want to tell everybody, so why did we even need a dragon in the first place? Why did we want to build one? So many, many years ago, when I became interested in firebrands, the first thing we wanted to do is, well, what are firebrands? I mean, I read a lot of literature, and I was trying to understand, and I found that there wasn't a lot of data what firebrand sizes are. So the first thing we did is we went to the lab and we said, look, let's just burn some trees and try to see what firebrands are. So I hope there's a lot of students on the talk, because one thing that students should understand is this isn't rocket science. It's just that, as a student, you should always think, if there's something you're curious about, what's the reason it doesn't exist? Maybe you should just think about an experiment or think about a model and just do it. And this is the idea. It came from that. Just, I couldn't find any data on this, so let's just do it. Let's burn it and see what's happening. And so we did these experiments, and we collected firebrands basically from this. And we tried to measure it and get information from the sizes. And then from this, we decided, well, let's do some simple laboratory experiments so we can then simulate firebrands in the lab. And for vegetation, we simulated it as these Douglas fir pieces. And for structure firebrands, we simulated it as these discs. And the idea was, well, let's just build a simple apparatus and put it in a small scale wind tunnel and understand these effects. So this is experiments we did many, many years ago to look at these kind of processes. And what we found basically, at least from those simple laboratory experiments, is that it's very important if you want to understand, let's say, the fundamental process of ignition. But we couldn't understand, for example, what are the vulnerabilities of structures to ignition from firebrand showers. Or in those simple experiments, we also couldn't understand the physics of firebrand transport, and also like under what conditions firebrands would actually accumulate. Since in the laboratory, we were just simulating the accumulation, but we have no idea if that exists in a real situation or not. And so we also found from those initial studies that it was actually quite difficult to actually ignite fuel beds too from a simulated type of experiment. But even though you see in real fire situations, firebrands seem to be igniting many different kinds of materials. So the idea was that the laboratory insights gave us insights, but it just wasn't enough. We really needed new approaches. And also, we looked around and there wasn't any information on, for example, what are firebrand size information from actual fires. The Japanese have done a lot of studies, I guess not a lot, but a few good studies on urban fires. So for example, what are the firebrand sizes from urban fires? But when in the US, I looked around, we didn't find some information about, what do firebrands actually look like from actual WUI fires. And so with a colleague who had retired from CAL FIRE, Ethan Foote, Ethan had done some interesting research on the Angora fire in 2007. So we partnered with Ethan to develop a paper to actually look at, some simple burn pattern analysis to understand what are the firebrand size distributions in actual fires. So once again, for the students, this is not rocket science by any stretch of the imagination. It's just that, what do firebrands look like from real fires? And we had a unique opportunity to try to get some information from this. So with that, we decided to construct the firebrand generator, which we call the Dragon. And those of you that can read kanji or Chinese characters can read dragon there. And I'm not showing videos today because I wasn't sure they're going to even work. So if you want to see the videos, I can send you. This is the Dragon actually working in a full-scale wind tunnel. And so the idea of the Dragon is that how can we simulate these showers onto structures in actual fires? So over the years, we developed many capabilities with this. Currently, we have a continuous feed full-scale firebrand generator, which lets us sort of feed chips for a limited duration and generate firebrand showers. And I like to refer to a tale of two dragons. So we also developed a bench scale device, and it's also really cheap, basically. What's important for people to understand is the Dragon is not, it's basically tubing. So there's nothing that's really super expensive for the technology. So basically the bench scale device is basically this tubing that you can see here. And we use these devices in different wind facilities here in Japan. We can produce different kinds of firebrands. So whenever we want to feed into the device, we can produce firebrands that we track back to what are similar to structure firebrand production versus, let's say, WUI fire production. So a lot of this has been described in our papers, and in the interest of time, I don't go into detail here. And the technology that NIST developed has basically, been used in other places. So for example, those of you that are familiar with the IBH facility, they have a whole series of these dragons that are there. And in Adai, in Portugal, they also have they clone the bench scale continuous firebrand generator. So they're operating that in Portugal. And as I'll talk about a little bit later as part of ISO, we need also to develop a globally harmonized device that everyone could use basically all over the world. So that's something that we're trying to work on in ISO TC92WG14. And some of the work we've done with the Dragon, I'll talk about. There was interest in looking at firebrand penetration through building vents. So before we did any experiments, we did a lot of numerical simulations, looking at flow profiles. For example, like would an E vent give you more penetration versus a gable or foundation vent? So these are very simple numerical simulations that we did many years ago. And then this led us to actually do experiments on firebrand penetration through vents. So what we did here is basically, codes were basically indicating that there's a certain mesh that you need for firebrand penetration. And to our knowledge, nobody ever did an experiment on it. So, the idea of the Dragon is since you have a new technology, you just want to experiment with it and see if any of this stuff makes any sense. And, we saw firebrands simply penetrating through the mesh and igniting materials behind the mesh. So as a result of that, we worked with ASTM and NIST together. ASTM had developed a bench scale apparatus for firebrand resistant vent technology. And since we had the Dragon technology at the time, we had done a collaboration with them. And then this collaboration is included in this test standard. So if you're interested in the test standard, you'll see in the appendix and all the discussion about the collaborative work that we did. So the whole idea was that, we want to develop good test methods. And so how can we help, develop the test methods in the best way possible? So this is the main focus of this. And also there's a current roof test method. So Dr. Suzuki gave me this image, which was courtesy of the Japanese test. But in the US, they use the same experiment. So you put a wood crib on a simulated roof deck. and basically you apply a wind flow. So in the US, it's about 5.3 meters per second, I think 12 miles an hour. And Japan is 3 meters per second. And then you look at what happens to the roof assembly. And we use the dragon to look at these kind of effects. So for example, everybody believed that Spanish tile roofs might be very vulnerable. I mean, not vulnerable, but would be resist ignition because, I mean, ceramic doesn't burn, as you know. But the idea is that, how do you look at the effects of the firebrands penetrating under the tiles? And so we also did work with industry on a similar phenomenon, looking at melting of underlayment for these kind of experiments. And this is another experiment looking at decking. So we did a whole series of experiments. There's actually 3 separate publications looking at decking and ignition by firebrand. And then we compare that to mulch. So for example, what you're looking at here is this is just measuring time to ignition from firebrand showers. And you see that under certain conditions, some of the decking assemblies have similar ignition to wet mulch. So it's interesting to see these kind of effects in terms of, how do we compare and review the various experimental studies that we've done. And this also leads us to, once again, how can we develop experiments that are simple to use and also could help us develop standard testing methodologies and also inexpensive. And so the idea here is mock-up. So what we did is a series of full-scale experiments looking at penetration of firebrands into roofing assemblies. And what's happening with that. And then the idea is that can we build a mock-up, so a much smaller specimen of a roof. So here you have just a small section, like a 0.6 by 1.2 meter section. And then looking at the firebrand penetration into these mock-up type of assemblies. And then what you can see is that, even though you're doing a much simpler experiment and it's much cheaper to run, you can still look at the same physics of penetration. So for example, firebrands will accumulate the tiles, and then you can get these kind of effects of firebrand penetration under the tiles and interacting with the bends. So a very simple experiment could lead and understand these type of physics of these processes. The other thing, of course, that my colleagues at NIST have done a lot of work on is fencing. And I'm hoping in the future they'll give a webinar as part of this series as well on some of the work they've done, because there's no way I could talk about that today. We've done some work here in Japan looking at the interaction of fencing assemblies with basically simulated walls. And the idea here, once again, is can we use a mock-up? So what I mean by mock-up is this is a very small scale piece of a fence, basically. You can see this is a 0.6 meter by 1.2 meter long. So it's something very small. And the idea is that, can you look at similar kinds of ignition behavior using a mock-up assembly? And, here's a picture of a fence interacting with the simulated wall from such kind of mock-up assembly. So you could get insights in terms of different potential fencing designs or things like that if you want to try to mitigate these type of ignitions. Because the idea is how can we come up with strategies to mitigate these ignitions and, use different kinds of materials in the future. Also, some work we've done was related to, some World Heritage sites. These are some issues, for example, historical structures. So, for example, if they're lost, it's a big problem. And so the idea is that, we developed a mock-up. This is, once again, a mock-up of a thatched roof. So you see that's the actual thatched roof. Here's a mock-up of the assembly. So this is a very small sample. And then, the dragon was interested in meeting that thatched roof. So here they're having a nice discussion. So, and you can see that, you can look at the dragon to understand the ignition mechanisms of the thatched roof. And then you could develop mitigation strategies. For example, how could you, because obviously what's important is we don't want ignitions to happen. So how can we mitigate these type of ignition events and look at these kind of effects as well? And recently what we've been doing, which hopefully I'll be able to show you, there's a fire materials conference that was supposed to be happening in 2021. The status of that is sort of unknown because of the pandemic. But we have been doing experiments also looking at over various scales of the firebrand deposition processes. So for example, here's the dragon attacking different kinds of obstacles in the flow and looking at how firebrands deposit and other kinds of effects as well. And the last thing I'll talk about for the research is recent combined radiative and firebrand flux on ignition. So I showed you in the initial figure the graph from Dr. Suzuki showing the coupled effects. So the idea is that now we've coupled a radiant panel with the dragon, and we can actually look at how does radiation in combination with firebrand showers result in ignition of fuel beds. Because as you know, Firebrand showers, of course, alone are important, but it's interesting to see how these coupled effects resolve. And also, this paper, once again, is open access, so if you're interested, I can definitely, you can download it. So in order to try to keep to the time, I want to now move into quickly what we've been trying to do in ISO. Basically, the history of the ISO work is back in 2017, I was asked, actually by Patrick Van Hees, who was the ISO TC92 chair, to give a talk to ISO because Patrick was very interested in the work that we had done with ASTM. And I gave this talk, that's the talk there, basically, you know, how do we harden structures? And ISO people were really interested in this. So because of this, there was a discussion to basically make a new task group called TG3. And the idea of a task group is that it's a short-lived event that reports to the ISO structure to talk about what can we do in ISO on this problem. So what we did is, as part of the task group, we had a workshop, which was an open call, which we had people from all over the world come and present. And it's described in this publication. And then also we published several papers in an ISO TC92 special edition about this. And if you're interested, I could send you this and you can read about this as well. And so because of that, TG3, there was a lot of interest in what was happening in many different countries. ISO decided to make a formal working group. And a working group has much more, I guess I would say, like authority to do research and other, not research, but actually do activities. You know, a task group just basically advises ISO what to do. And the ISO task group's advice was we need a working group. We need to develop new standards. We need to actually start doing things on this problem because it seems to be a really big issue. So since I was sort of dragged into the TG3, they sort of dragged me into the WG14. So I'm convener of this WG14 Law Director Fires in the Built Environment as well. And what we basically have is we have these current membership from different countries. So we have representation from the Netherlands, Sweden, the United States, United Kingdom, Japan, Italy, Germany, France, Canada, Australia, and Austria. If you're interested, I think ISO has something like 35 member countries. So if you're interested in becoming a member of ISO, you have to speak with your local standards organization body to become a member. And the first charge we're developing in ISO is that we want to develop a document which basically describes a global overview of different approaches for standardization. So for example, what are they doing in Australia versus what are they doing in the US versus what are they doing in other countries? And so the idea is that that's one of the main focuses of that. The other thing we've done basically is that you might be surprised to know that ISO itself doesn't have any definitions or terms for most of the things we talk about in outdoor fires. So when we actually talk about a lot of the stuff I presented today, like firebrands or you know, WUI or all these kind of terms, which many of us on the call know about, ISO has no actual definitions for this. So WG14 suggested that ISO reconvene WG8. WG8 is actually a working group that develops definitions for ISO. And so they've reconvened this working group based on the proposal from WG14. And the idea is that how can we actually start to include these outdoor fire terminologies in the ISO lexicon? The other thing that's currently out for ballot as well is that ISO TG92 WG14 proposed to develop an ISO standard firebrand generator. And this ballot is currently out. But of course, the idea here is that, you know, we developed a firebrand generator technology at NIST many years ago, and various organizations have used this type of technology. But it's important that we, you know, and the working group agrees, this was the main discussion, that we want to have just a globally standardized device that everybody can use. So this is currently out to ballot, and we're hoping to have some progress on this. And also, just to give a plug to mainly students, I think, on the call, because we developed an encyclopedia of wildfires and wild and urban interface fires. As I think as Sarah will tell you, or as Saka will tell you, you know, when we started working on this topic many years ago, there wasn't any resource where we could just, like, you know, like a reference where you can get a lot of information on these things. So Springer Nature contacted me and said, look, you know, we'd like to develop an encyclopedia. And my first reaction was, you know, like my head kind of exploded because it looked like it's like a huge amount of work. But then I thought about, you know, we should do it. So then I reached out to several colleagues to help me. And we tried to develop the first round, so we have the first cut of this device, this encyclopedia, and now we are developing a second edition, and we hope to make that much better than the first edition. But you know, the first edition is getting a lot of interest because there's a lot of great contributions in there. Like, I don't know if Marty Alexander's on the line, but Marty wrote some great contributions for this encyclopedia, and those are receiving a lot of downloads and a lot of interest. And you know, we had more than 200 authors from the community. Vito also wrote for us on firebrands. If Vito's on the line, so and Steve Quarles and Dan Gorham, if they're on the line, wrote a lot of great things for us. So, you know, a lot of people came together and worked on this, and I talk about this often because I'm just so happy that people worked on this, and because I think the technology transfer is really critical and really important to, you know, share this knowledge and have it in a one-shop stopping, so you know you can understand all the stuff that's basically there. So I think with that, I'm done. I try to keep it to 50 minutes. What I want to do is thank everybody for joining this. Hopefully it was successful, it was worth your time. And also I want to give a plug for the next webinar. So Dr. Suzuki will be talking about urban fire management in Japan. I really encourage you to join this because, you know, when we think about WUI fires, you know, people often don't, for whatever reason, think about urban fires. But once a wildland fire reaches a community, you pretty much have an urban fire that's occurring. And so Japan has been dealing with urban fires for many, you know, more than hundreds and hundreds of years. And so finding out the information that what Japan has done is difficult because, as you can imagine, if you don't read Japanese, you probably can't find it. So Dr. Suzuki is going to break it down for you and also give you a talk about some of the research that they've been doing in Japan on the urban fire problem. And I think it's directly relevant to the WUI fire problem in the US and other countries. So I encourage you to listen to this. And that'll be on December 15th. And once again, we would like everybody to join LOF&BE. It's free. And if you'd like to give a webinar, we would love to hear from you. We want to have everybody's voice and we want to hear from everybody. So it's important that, you know, we really need your help on this activity. And with that, I'll turn it over to Sarah. And as Sarah mentioned, we'll try to answer the questions if there are questions today. And if anything is after that, I'm considering we might actually just make another report where we'll probably put together all the webinars, like maybe the first 6 webinars, and then maybe we'll try to have some summary of the questions or whatever for everybody to have. That might be one idea, because I don't think we can get to the questions and everything in time with the time that we have. So thank you.